All right, let's dive right in. Now, if you're someone who directs projects using AI to build software, this explainer is for you. We're not going to be learning to code today. Nope. Instead, think of this as a masterclass in architecture. It's about understanding the one technology that can transform you from someone who just writes prompts into a true project architect. So, to really get why TypeScript is such a game changer, we first have to talk about where it all comes from: JavaScript. For, decades, JavaScript has been the language of the web. It's incredibly flexible, it's dynamic, but when you're trying to build really big, complex applications, that flexibility can start to feel a lot like, well, chaos. And that's really the core problem, isn't it? Building a massive, complicated piece of software with just plain JavaScript can feel exactly like this. You have all the freedom in the world, but you're missing a solid, predictable foundation. Every new feature you add, it's like adding another floor, and it just increases the risk that the whole thing could come crashing down because of one tiny, hidden mistake. This comparison just nails it. With JavaScript, you're like a craftsman building as you go, figuring things out on the fly. It's creative, sure, but it's also pretty risky. TypeScript, on the other hand, it hands you a detailed architectural blueprint before you even start. It makes sure every single piece is measured correctly and fits perfectly. You trade a little of that make-it-up-as-you-go freedom for a whole lot of confidence and predictability. So, with that in mind, let's meet the hero of our story. If JavaScript is the Wild West, you can think of TypeScript as the town planner who shows up to bring order, structure, and a clear plan for the future. At its heart, this is the simplest, most powerful way to think about it. TypeScript is still just JavaScript, but with this extra layer of rules on top. These rules, they're called static types, basically define the shape of your data. They're like a contract, and TypeScript's whole job is to act like a building inspector, checking that all the code follows those contracts long before any user ever gets their hands on it. I absolutely love this analogy because it just makes the whole concept click. Think about writing a document, right? You've got that spell checker and grammar tool catching your typos as you write. They don't change what you're trying to say, but they make sure the final document is clean, professional, and easy to read. That is exactly what TypeScript does for your code. So where does this thing actually live in the whole ecosystem? This is super important. It's not a framework like React, and it's not a library you just plug in. It's a tool that you and your AI use only during development. You write in TypeScript, but it gets translated or compiled into plain old JavaScript before it ever runs in a web browser. So the magic happens entirely behind the scenes, making the final product way, way stronger. Okay, so how does this actually work in practice? Let's walk through the whole life cycle, and let's imagine it's like a modern factory production line. It's really just a simple three-step process. First, you've got the plan stage. This is where we're designing. Our AI is writing code in these special TypeScript files, and that TypeScript inspector is constantly checking if every part matches the blueprint. Then we move to the compile stage. Here, all those special blueprints and notes are stripped away, and everything gets translated into standard JavaScript. And finally, the execute stage. That clean, simple JavaScript is what actually runs in the browser. And this right here is the key takeaway. All of TypeScript's value, all of its power is delivered upfront during that planning phase. It's a quality control process, not something that runs live with the app. And the results? You get a final product that is just fundamentally more robust and reliable, because it was built on a solid, verified foundation from the very beginning. Okay, this is where that blueprint becomes your most powerful tool. As the project architect, how can you use this to completely change how you work with your AI collaborator? This is the perfect way to think about it. When your AI generates TypeScript code, it isn't just spitting out logic anymore. It's also forced to define the contracts for that logic. It has to be explicit. And this means the AI can actually catch its own mistakes, making its output way more consistent and reliable right from the start. Now, what I love about this slide is that it's basically a cheat sheet for you, the director, to spot quality. On the left, these are the signs of a healthy system. This is the good stuff: clear, reusable blueprints, the AI is following the rules. But on the right, these are the red flags. These are the warning signs. Things like any or @TSIgnore are basically the AI's way of saying, you know what, I give up, I'm just going to sweep this problem under the rug. And that's your cue to step in. And when you do see those red flags or those compiler errors, don't think of them as failures, really. Think of them as the beginning of a really productive conversation. TypeScript errors aren't just problems. They are precise, actionable feedback. You can use this feedback to give your AI much, much better instructions. Instead of just a vague "fix this," you can ask sharp architectural questions. You're using the blueprint to guide the AI toward a better, cleaner design. You're actually teaching it how to be a better architect. So let's bring this all home for the final, most important insight. This is the idea that takes TypeScript from being just a useful tool to a core philosophy for building software today. Catching bugs early is a fantastic benefit, don't get me wrong, but it's not the ultimate purpose. It's really just a symptom of something much deeper, something way more powerful that's happening inside your project. The real goal here is to create code that is, for lack of a better word, intelligent. And what I mean by that is code that carries its own documentation, its own rules, and its own understanding, baked right into its very structure. So what this really means is you're building a system that is self-describing. It communicates its purpose not just to the computer, but to any human developer or any AI that comes along and interacts with it later. That makes your project so much more maintainable and easier to build on. And here it is. This is the aha moment. We can call it design time intelligence. This is the big idea. Your code can be smart and communicative long before it's ever actually running. It creates a whole new level of collaboration, where the code itself becomes a shared language between you and your AI. And once you understand and start using this design time intelligence, your role completely changes. You are no longer just giving instructions and hoping for the best. You are designing the blueprint. You are establishing the rules of the entire system. You are orchestrating a collaboration to build something truly solid and elegant. So I'll just leave you with this thought. You have the blueprint now. You know how to create intelligent code and how to direct your AI with clarity and with confidence. The only question left is, what masterpiece are you going to build?